Welcome to Energy Talks, a regular podcast series with expert discussions on power system testing topics. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. Hello, everyone. In this episode, we will discuss the role of intelligent secondary distribution substations, also known as ISDS, in rapidly expanding distribution power grids. And we will find out how ISDS components can support operations and facilitate the planning of future grid expansions with high reliability and efficiency. Joining me for this discussion is Florian Fink, OMICRON expert for the testing of industrial and distribution grid applications. Florian will also tell us about new automated closed-loop testing approaches for ISDS that have been developed to ensure efficient and safe asset operation and maintenance. Florian has been an expert guest of mine in previous episodes. Hi, Florian. Welcome back to Energy Talks.
Hi, Scott. It's great to be back again.
It's great to have you here with us for this discussion. Florian, could you please describe how electrical grids are changing and what is influencing this change?
So at the moment, we're seeing a lot of decarbonization initiatives are running, and this will have all influence to the power grid. So a lot of new renewables are coming to the grid. So the DR, distributed energy resources like solar or photovoltaic, wind energy or hydro energy, and besides that, also the electrification is going on. So we're seeing new loads coming to the grid connected, the electric cars, the heat pumps, and all that is currently changing how the power grid will behave in future.
What is driving the need for grid expansion, and how are grids being expanded?
So the points I mentioned with the renewables and the new loads, of course, will lead to a different load flow that we had in the past. So we see more and more load flow in the secondary distributions, and even the load flow is different than before. Before we had it from a centralized generation, and now we have it more in the secondary distribution where it goes directly from the generation like the solar or photovoltaic to the electric cars. And therefore, this load flow, need to be more controlled.
Florian, what are the major ways electrical grids are challenged by expansion?
So important is to know the weak points and where they need to be extended. So as I said, with this load flow, we have also voltage problems. So the voltage dip or voltage rise can be a problem due to the generations or the new loads. And the difficult question here is the speed of the impact. So as we seeing now all these new things coming, we can't build that fast, the power grid. So therefore, it's a big challenge here.
What is meant by an intelligent secondary distribution substation, also known by its abbreviation ISDS?
So these intelligent secondary distribution substations are small switchgears with a transformer, I think we all know, close to our households. Before there was a small transformer in a medium voltage switchgear and a low voltage switchgear where the cables to the houses are connected. And as I said before, here we see now with the houses, the heat pumps and the photovoltaic and the electric cars are connected. But in the past, they were not really active. So they were just passive distributing the energy. And now they are not really becoming intelligent, but they are starting here to measure, and you even can control them from remote. So that's meant by these intelligent secondary distribution substation, that you have the possibility to know what is the load flow and even to control it from remote.
Florian, how does the constant availability of real-time data of the network status enable the ISDS to be remotely operated and monitored?
So the big advantage is here in that approach, like these customers using that they can communicate via SCADA to remote control it, and have an IoT channel to collect the data. So they use the SCADA connection to operate the intelligent secondary distribution substation, to change the open point of the ring, and they use the IoT connection to collect the data for further grid status and even the planning. Because here is a difficult thing for the investment, but also from a timing point of view, to steer the investments and the manpower correct in the secondary distribution grid.
Okay. What are the smart components of these substations and what are their functions?
So on the one side, we have there now in the medium voltage area, but also sometimes in the low voltage, sensors connected. So these sensors now are starting to measure and bring the values of current and voltage into the SCADA or IoT. In addition, we see their short circuit indicators, or even they can do more than indicate the ground and short circuits. They can now connect these sensors and bring the data to SCADA or IoT. And in addition, of course, we need telecommunication connecting to SCADA and IoT over the network.
Florian, please describe why it is important to validate these smart components in an ISDS and how often should they be checked?
So the important thing is when you install such things that it is ensured they deliver the correct data. For example, if you would have a fault on a ring and the short circuit indicator would indicate in the wrong direction, the guys in the control center would switch off the wrong cable or line. So it's important that they are working. Due to the high numbers they will be installed, most of the tests will be performed in a factory acceptance test, because these substations are not like in the 110 kV where we have multiple days of commissioning until the system runs. It has to be much faster integrated into the grid, and therefore the factory acceptance test is a great possibility, because we have here also a high possibility of standardization, and that will speed up everything much faster. In addition, we need experience about the operations, because therefore we get also an indication how much failure over time we get in these components. But I think that most of the tests will happen after retrofit after several years, as we have here now also electronic components in such a switchgear after, 10 to 15 years. So will be retrofit, and then the new system will be recommissioned.
Okay. Florian, how are these smart components tested to validate their reliable operation in the ISDS?
So what's always good for testing, to do a system testing approach. So to test overlapping functionality and verify if every component is working. So as I said before, it's good to standardize as much as possible, and therefore use also standardized tests which are automated, and injecting values and verify that the values are configured, or so that the devices are configured correctly and the values are displayed and forwarded correctly.
Okay, what new automated testing approaches have been developed to provide operators with the data they need to plan asset operation, maintenance, and grid expansions?
So in this direction, OMICRON always tried to automate their tests so that they are done very quickly and in a standardized way. So therefore, we are using in different testing solution a templating approach, and that gives us the possibility, as I said before, to speed up the test, but in addition, it ensures the quality of the test. For that special thing here, we even create this possibility of a closed loop test, where we can inject with our test set values and validate them directly within the same software. And that speed up the test significantly, because there is no manual interaction needed. And this standardization really helps here.
Okay. Florian, what was the perceived or real need that led to the development of an automated testing approach for ISDS?
Yeah, the massive numbers of planned installations. So as I said before, we are not in a 110 kV substations, so you can't afford 1 or 2 days of commissioning of such a switchgear. It have to be done in area of half an hour or something like that. So that's something we would like to achieve, and that's possible with the solution we have here.
Okay. How did OMICRON become involved with the development of this automated testing approach?
A colleague of mine has seen a LinkedIn post, and this LinkedIn post we have seen the new concept of this intelligent secondary distribution substation. And then we approach the customers and ask them, what's your idea for doing the commissioning of such switchgears? And they were exactly on the same point and said, yeah, we would like to get more into that thing because we have exactly here a pain point. And then we scheduled together a common workshop where we collected all the needs and searched for a good solution. And that has been developed in a quick time. So we could suggest them several approaches and they were happy with that one.
Okay, very good. Just to clarify, the customer had written the LinkedIn post, is that correct?
Yes, that was correct.
Yeah, and they were addressing their general situation, or had they already started to develop such a testing approach?
So they did manual tests like in a commissioning, so as it is in a prototype status, or it was in a prototype status. So they tested it manually, like normal commissioning, but that took again multiple hours with multiple persons. And they know that this would need to be improved. And then it was perfect timing that we come with the automated approach.
Okay, and what types of testing equipment were they using in this first round?
So in the first round, they were using CMC test set, so our known protection test set from OMICRON, but in a manual interaction. And then we showed them the possibility of the automation and even of this closed loop test, and that really helped here.
Very good. How does automated testing with a closed loop approach ensure maximum efficiency, and how exactly is it performed?
Yeah, as I said before, even for this closed loop approach, the CMC was used. And what the CMC is doing here, it, like always, creates analog values. In this special case, we have these medium voltage sensors where you have low level signals to inject. So for that, we have a special accessory for the CMC available. So the CMC inject into this short circuit indicator. And in this case, the short circuit indicator creates 104 data. And as we are not able to read that 104 data with CMC, we used a gateway that converted the 104 data to IEC 61850. And with that, we were able to use in Test Universe the client server module and do the closed loop test. So we did just the mapping as it was standardized in the gateway from 104 to IE61850, used the client server module, injected the values with that, and directly get the feedback if all the values who were injected are correctly and the configuration was correct.
Very good. Could you please explain how stable data transmission and correct parameter settings play a role in automated ISDS component testing?
The data we got from such a system must be reliable, so that the colleagues who are doing the planning for the grid extension, the colleagues in the SCADA operation center need reliable data to work with that, to do the operations, to do the planning. It need to be ensured that everything is correct here. And here the automation really supports that.
How long does this type of ISDS component testing take? What are the aspects of this type of testing that save time?
When the customer worked first on the prototype, we were talking about more than half a day with multiple people. And now we can do it less than half an hour with that automated approach. So as it planned to install 400 of these substations per year, that's a massive speed up and gain of efficiency we have here.
Okay. Florian, you had mentioned this before. I just want to repeat the question. Is this type of testing performed regularly? And what are the criteria that indicate the changes that need to be made in the grid?
We think to see that tests mostly in factory acceptance test. Due to the efficiency, we can use a clean and dry environment where we can have the CMC installed, and this speed up the test. I think on site there will happen some quick checks to verify if everything is working correctly. Even there are sometimes sensors which could be only installed when the medium voltage cable is there. And therefore we have a great tool, and that's the Compano 100. The Compano 100 has an advantage. There's a battery. So this battery operated device without need of an additional PC is very good for this field use, and therefore you can inject primary values which normally totally are enough to trip or operate such a short circuit indicator. And with that you can verify and check also with the colleagues from SCADA if all the values are correct.
Okay, and why would you perform these quick checks?
The quick checks are just, again, a functional check. So you would not try to test every parameter or every setting. So that should happen normally in a factory acceptance test. But the quick check gives you an indication if the sensor, for example, is installed in the right direction, or if the whole system is working correctly, including, for example, telecommunication.
Okay, very good. How is the data documented, and how does it allow decision-making regarding grid operation, maintenance, and expansion?
For sure, the data is connected to SCADA and there is a documentation or data storage is handled. In addition, this customer has also an IoT database where the data is stored in a much higher resolution because they need it for their grid planning and to see even some effects coming from the new loads which haven't been documented before. And they even have a system available where they can have a live overview from the operation guys to get indications what is happening in the grid. Even when they are in front of such a switchgear, they can use the smartphone to check how is the load flow.
Okay. Florian, how can our listeners get more information about automated ISDS component testing?
So in the first issue of the OMICRON magazine in 2023, we will have an article where we described the testing approach and how the customer created the concept more in detail. In addition, we had this year in 2022 a paper at the CRED, so that's also available from OMICRON in the customer area. So here we describe very in detail how testing and the whole concept worked. And if you have further questions, you can contact me via LinkedIn using this channel to ask me questions directly.
Thank you very much, Florian, for taking the time to tell us about new automated testing approaches for ISDS in this episode of Energy Talks.
Thank you, Scott. It was great to be here.
And a big thank you to our audience for listening to this episode of Energy Talks. We always welcome your questions and feedback. Simply send us an email to podcast@OMICRONenergy.com. OMICRON has several years of experience in power system testing and offers you the matching solution for your application. For more information, be sure to visit our website at OMICRONenergy.com. Please join us to listen to the next episode of Energy Talks. Goodbye for now, everyone.